welcome to the first panel discussion of the day. So we're going to be covering the testing and specification of steelwork for reuse. So just so everyone's 100% clear, we're talking about steel that is removed from an existing building, cleaned up, refabricated, and then used in a new development. Might go back into the same building, different site, doesn't matter. But before we get into the detail, just do some introductions quickly. For those of you who don't know me, I'm Penny Gowler. I'm a Chartered Structural Engineer and Head of Sustainability at Elliott Wood. I'm currently directly involved in one very large steel reuse project, which will be featured in the case studies after this session. I've also written quite a bit of guidance on circular economy and steel reuse, primarily for the Institution of Structural Engineers. So we're just going to introduce all the panelists. Can we go to Peter first? Do you want to just do a very quick, less than 1 minute intro, please?
Good morning, all.
Is it working?
Good morning, all. Peter Muszynski. I'm Chartered Structural Engineer with 20 years in construction industry, spanning design and client engineer. Currently working for Zurich Insurance, providing technical insight for underwriters to assess their construction risks.
Thank you. Michael?
Hi, everyone. For those who don't know me, I'm Michael Sansom. I'm a chartered environmentalist. I'm not a chartered structural engineer, so no tricky structural questions. I'm currently manager of sustainability at BCSA, but before that, I was at SCI for over 20 years, colleagues with David. We first did a reuse study about 20 years ago for British Steel. It didn't go anywhere until about 6 or 7 years ago. We worked with Cambridge and then followed on to some European projects. And then on the back of those, we co-authored with David P427. At BCSA, I now run a steel reuse working group that many of you are on, something like 40 people, and we're trying to coordinate, identify guidance needs.
Thank you. David, next.
So I'm David Brown from the SCI. I've been there nearly 30 years. I'm much more comfortable talking about lateral torsional buckling. So if you want to ask me a bit about that later, that's good. With Michael, I was one of the joint authors of P427, which I suspect a lot of people know. And I was the lead author of P440, which is a supplement to P427. So kind of a technical anorak-wearing sort of guy, really.
Thank you. Jonathan?
Hi, I'm Jonthan Davis, Associate Technical Director at William Hares. I sit on the BCSA Sustainability Committee and I chair their Reuse Committee. We've been helping clients for the past 3 years trying to get cost and carbon viable solutions into industry. We've run a few test pieces with OMR through our facility and tested the principle. And I would say about 60% of our tenders now have a reuse ambition. So we're extremely excited moving forward. We should see our first significant project hit site back end of this year, about 150 tonnes in a 3,000-tonne project. And then we should see the second early next year, which is about the same, 100 tonnes in 4,000 tonnes. So we expect the market to grow quickly.
Great. Thank you. And Laura?
Thanks. Hi, I'm Laura Batty. I'm a chartered structural engineer and I'm an associate at Hain Tillett Steel, where I run the research and innovation team. So we look at emerging topics in structural engineering, and a big part of that is reuse of steel. I have been working on that for about 2 years and have been also involved in a project with Innovate UK on reclaiming steel from 1950s building, which I'll talk to you about in a bit more detail later.
Thank you. So I know that we've got an educated audience here today, so we're just going to jump straight into the detail. We've got a lot to cover, so we'll see how we go. Bear with us. So just to frame the beginning of the discussion, one of the reasons that steel reuse is taking off so rapidly at the moment is the steel reuse protocols that have already been mentioned by Michael and David. And the reason that that is helpful is because it provides a way to get to a CE marking of the fabricated steelwork at the end of the process. So, David, you've already mentioned that recently you published a new guide or a new steel reuse protocol, P440. Can you just give us an overview of the two protocols, why P440 was needed, and what the testing requirements are for steel for the two for the two protocols, please?
Sure. So P427, I suspect many people will be familiar with it. I think it established some really important principles about grouping. So members which had the same function, they are, let's not say identical, but they are very similar. It identified the principles of hardness testing to make sure that everything actually did belong to the group. And then one option was a destructive test, just to make sure that we knew where we were. Or alternatively, you could undertake more destructive tests, and then you could apply some statistics to it. So that's kind of a bit of a background to the grouping, which I think many people will find important, and then the testing of that group. Once then you've established the strength of the steel, perhaps the only design issue really was the gamma M for buckling, so a little bit down-rated, a gamma M value of 1.15. The other key feature of P427 was that it was for steel which had been used in construction after 1970. And there was a good reason for that, because there is manufacturing production data available which tells us about the average steel strengths over an awfully large population of tests produced by the manufacturer. So we were aware of the statistical distribution of that strength after 1970. So that really is the start and finish of P427. But then people were saying, well, we want to use steel from earlier. So, okay, there was a demand for that. So we then provided a supplement in P440, which goes all the way back to 1932. Why 1932? Well, that's when BS449 was introduced. So we know about buckling curves, we know about buckling behavior all the way back to 1932. So we could look at the performance, we could look at, to some degree, the reliability, and then the task was to produce slightly different buckling curves, just to be conservative. So P440 has got slightly different buckling curves. It maintains the same gamma M value for buckling, 1.15. There is a little bit of conservatism in that for cross-sectional resistance, we still recommend 1.05. So just a little bit of conservatism. But I think those two guides together mean that we can have some degree of confidence about reusing steel all the way back to 1932.
Brilliant. Thank you, David. Very helpful. And Laura, you've been undertaking a project recently where you've been looking at salvaging 1950s concrete and case steel. And that was, I think it's worth saying, before P440 was released. Do you just want to give us a bit of background as to your experience?
Yeah, sure. So like Penny said, it was before P440 was, I mean, I'm sure it was in the works, but I hadn't heard of it. So the idea was to apply for Innovate UK funding to look at a project in Belgravia that was being demolished. The steel was erected in 1950, and it was concrete encased. So this was definitely outside of what would be feasible within P427, but also kind of economically advisable because it just is really quite difficult to reclaim. But we went for it anyway and got the funding, and with the approval of the client, we're able to salvage 10 beams and remove the concrete encasement and do materials testing. And when the materials test data came out and was being analyzed was more or less the same time as P440 came out, and the results and the insights that we got matched what the advice was from P440. So we tested tensile yield strength, elongation, chemical composition, impact toughness, and found that the results were kind of a good case study for the insights provided in P440.
Thank you. And David, you've had some feedback from others that have been doing testing. Do you want to just give a bit of overview of that?
One of the things that people remark about in P427 is that there is a relationship provided between hardness testing, which is cheap and convenient and quick, a relationship between the values you get for that and the measured yield strengths and measured ultimates, if you actually put them in a test machine. And it's known that that relationship is conservative, so there is an opportunity. Could we dream up a better relationship? you need to look at the results, and the results demonstrate that they are all over the place. So there is apparently not very much consistency between hardness testing and the measured yield and measured ultimate that you would get from a laboratory. So for the moment, my view is we probably have to retain that relatively conservative relationship between hardness testing and what you think the steel grade is.
Is it fair to say, David, that when you wrote the original steel reuse protocol, the idea is that the hardness testing would be a bit more economical, so you wouldn't have to do so much sort of intrusive testing?
Absolutely, because it's quick and cheap. I think, and others might comment on this, that there is clearly commercial advantage in doing at least 3 destructive tests on a group, because generally the answer that you get from the destructive tests will show you a higher steel grade than you would have got from the rather conservative hardness testing.
Okay, thank you. And that quite nicely brings us on to Michael's question around the cost of testing. So from my experience talking to clients at early stages of projects, some of the first questions that we get asked are how much is it going to cost? So you've had some data on that through the reuse working group.
I mean, this is on the destructive side, not so much the non-destructive side. Yeah, we surveyed a number of test houses and people who are doing it, sitting up here, to get a feel for the sort of tests that are coming, the costs that are coming back. And I look at it a bit like rack rates, really, in hotels, in that you know, what they tell you is maybe different to what you actually pay in reality. And certainly there's a question of scale. If you're doing lots and lots of tests, like Roy's doing maybe at Cleveland, you get a much better unit rate. But typically, the sorts of values we were getting to do a suite of tensile, Sharpie, and chemical testing would be in the range of about £300-ish per suite. So every beam that you're testing, let's say for that suite, would probably be of the order of about £300.
Okay, thank you. And ultimately, the point of doing these tests is to understand exactly what steel we're dealing with, so that designers, like engineers, like ourselves, can design to the right material strengths. As a fabricator, Jonthan, what is it that you require from the testing in order to be able to then refabricate that steel and certify it?
I think it's worth starting by saying not everyone in a fabrication business is necessarily technical. We have non-technical stakeholders and technical stakeholders. So we need the audit trail, we need the structure that P427 offers. So if we don't know where the steel has come from, we need that admissibility report from the reuse specialist. We need to know that the steel has been designed with reuse in mind, taking on board the comments that David has made, so that we know the yield, for example, we know the subgrades, so we can design the steel connections, etc., appropriately. And then we use some of the chemical and mechanical properties to inform our welding procedures, our declaration of performance records that go towards the CE marking, etc. So the fact that it's traceable, it's auditable, and it's easy to communicate to the broader stakeholders within the business is extremely important to us.
Thank you. And I think it kind of brings us on to the other big question that clients always ask, which is insurance and warranties about steel reuse. We're very lucky to have Peter here from Zurich Insurance. Do you want to just give an overview of the issue of steel reuse from an insurance perspective and what you require to have comfort that we can use this steel work?
Yes, of course. The supply chain in construction industry can be very long and very complex. We try to help clients to transfer some of the risks within the supply chain, and you've got a number of products, insurance products, that support that. So you'll have a professional indemnity, public non-product liability for fabricators, constructional risk for the construction phase, and then at the end of it, property insurance. And also you can have a latent defect insurance if you're worried about your warranties. What we're looking at, when we see the project on the insurance market is for the evidence of the skills and experience in supply chain. And this is really important to insurers because the quality aspects or losses from poor quality are the top 3 in insurance industry at the moment. So it's important that you can, present how you're going to manage the risks. And that brings me to your risk management techniques. We want to see a good project-specific risk management and risk registers, not copy and paste, from other projects. And yeah, that's about it. Thank you.
Okay, thank you. So just focusing on CE markings now. So one of the main reasons that we do all of this testing is so that the likes of Jonthan, as a fabricator, can rely on that test data, refabricate a piece of steel, and then provide a CE marking or a UKCA marking now, post-Brexit. Michael, can you give us an update on the latest discussions you're having around CE marking? Because it's quite a complex subject.
Yeah, it's a bit of a hospital pass, that one. I mean, I think in P427, we set it out clearly that as long as you follow 1090 Part 2, the clause 5.1 that allows you to do it by testing, all should be fine in terms of CE marking. And I should say at the moment, of course, that CE marking is exactly the same as UKCA marking. So there's no difference yet. So, but I would say that that interpretation isn't necessarily shared throughout Europe. There's work going on in the SEN committee, TC135 are doing a technical specification following P427, but their view of the interpretation of the CPR isn't quite as clear maybe as we have in the UK. And I think it's fair that the more you dig into the CPR, it does get a little bit more murky and a bit more grey. But I think the principles are clear. If you're doing the right tests, you can CE mark. There's a requirement in there about inspection documents, but there's a note in there that you can use test reports. So we're confident that that's all fine. There are some issues with some derogations or exemptions relating to on-site working. Is that exempt? Yes, it is at the moment strictly applying the CPR, and there's also the possible exemption relating to series or non-series production. Again, we're clear that steelwork fabrication is series production with individual products. That gets a bit techie, and therefore that derogation doesn't apply. So in terms of what we're doing, our working group that Jonthan chairs, our BCSA group, that's one of our priorities, and we're trying to produce a succinct summary document spelling this all out, and we should be able to publish that soon. I would say that the department, responsible government department, I think their government, is OPSS, Office for Product Safety and Standards. They're responsible for regulation of construction products. And we approached them for a view on this in, I think, mid-May. And they came back with a big legal answer, which really was helpful, but really showed they didn't fully understand it. And as some of you might know, they've now started a research project because they might be contacting you for an interview. So OPSS are doing a study to understand the market with a view to how they're going to regulate structural steel and other products like precast and CLT and I think glazing systems. So we're pretty clear. We're going to publish a document shortly. CE marking is fine, and OPSS hopefully will be completing their work and publishing and issuing some maybe more authoritative guidance in due course.
Thank you, Michael. That's really helpful and really good to hear that the government are waking up to this issue slowly. Jonthan, from a fabricator's point of view, it does feel like potentially quite a lot of the risk is being transferred to you guys. Can you give us your view?
It does feel like the risk is getting transferred onto us. It needs to be as simple as possible. And I think Michael's already alluded to the fact that 1090 Part 1 isn't as clear at recognising reused steel as it could be. So there are some opportunities to fix that over the next few years. We're following the roadmap that Michael suggested of using 1090 Part 2. We've workshopped that with our external accreditor, SCCS, they're fairly comfortable with that methodology. So we would provide a DOP, Declaration of Performance, in the usual manner, but behind that we would put additional supporting information on that would tie into the test data specifically. We might adapt specific welding regimes for the reused steel that sits outside our normal welding regimes. So we're definitely having to do more work. It's definitely proving to us that the audit trail is paramount to the successful delivery. And we're looking forward to getting a few of these smaller jobs underway so that we can focus on larger schemes later.
Thank you. And Peter, from an insurance point of view, what's your view on CE markings or UKCA marking?
It's probably fair to say that self-certification would not be well received in the insurance market, so we would be looking for some sort of independent certification process. Also, the consideration of design life or structural life. So we design for 60 years, but insurance products come with, and warranties come with limited liabilities. So thinking about, sort of a knock-on effect on insurance further down the line when the building from reuse steel is in use.
Okay. So when you say self-certification and a third-party verification is required, will, following that steel reuse protocol, tick the box of third-party verification? Or are you saying that there needs to be another body involved?
No, I think as long as it's independent from a supply chain.
You can have that audit trail.
We can have an audit trail like a golden thread through
Okay.
quality process. Yeah, I think we'll be happy.
Okay, thank you. It's probably worth pausing there to see if anyone's got any questions. We've sort of covered the testing and CE marking that I was intending to cover, and then we're going to go into specifications. Does anyone have any questions? Oh, there are some questions. Okay, so question there from John Ward, probably one for David, I'd imagine. What are your views of grouping by chemical properties rather than by hardness?
Show me the data and I'll look at it. I don't have a view at the moment. I've only seen data which relates hardness testing to yield strengths.
This comment and this discussion with EMR in particular came about looking at the hardness plot that you're referring to, where you do just as well throwing a dartboard at it, throwing darts at it from a fair distance with a blindfold, and reflecting, you may get some grouping from there. Is there a better way of doing this? And yeah, we haven't got the data. This is something we need to get, but I'm interested in an initial view of that or alternative ways of doing the grouping, which is clearly critical to the whole.
Yeah, I'm absolutely supportive, but you and I need to see the data first of all. If there is a good correlation, that would be fantastic. Because just to reinforce the point that John was making there, I said earlier, when you do plot hardness tests against the measured values, you can choose your own line of best fit.
Thank you. And then a couple of questions from Andrea. Probably the first one coming to you, Laura. Do designers and clients need to know about these standards, or are they predominantly for reuse steel providers?
I think designers certainly need to know about them because it provides kind of testing protocol. It will affect the way you design with the reused steel. So certainly designers need to know. Maybe clients might not, but it's probably best that everyone's on the same page when doing something so non-traditional as designing with reused steel.
Yeah.
Could I just add to that?
Sure, of course.
I think the examples where we're seeing this succeed the most is where early collaboration is taking part, and it's actually being driven by the clients down the supply chain. So from our perspective, that early collaboration is yielding the most reward.
Yeah, and I would definitely agree with all of what you've both just said. I think it's really important that clients are brought along on the journey. And yes, they don't need to know all of the detail that perhaps we've gone into today and all of the various British and European standards, but they do need to know the overall kind of process and that these protocols exist. Yeah, I would agree with that. Sorry, David.
Could I just add to that? I think it's essential that designers know about them because particularly when you get to older steel, people will appreciate that older steel used to be riveted Nobody ever imagined the idea that it would be welded, and therefore the issues of the chemical composition would be important. Early steel, nobody cared about toughness. Again, that would be important for people who are reusing older steel, and those are design responsibilities. So absolutely critical that designers know about those things.
Definitely for designers, yeah.
Just to add to that, I mean, Steve and I had a meeting with CREG, which are the Construction Risk Engineers Group, a couple of months ago, and we went through all this, and they were generally happy with it, much happier than they were with timber. But the one point that they were picking up on was some designers weren't terribly comfortable, and indeed we've seen a few examples of that at BCSA, where they're not, of course they're used to design using new steel, but when they're going back to 1920 and they've got a whole load of tests, they weren't necessarily quite as comfortable with dealing with that. So CIREG suggested that it might be useful to have some form of accreditation of designers to redesign safely with reclaimed steel.
Thank you, Michael. Coming up, another question come up. So another one from Andrea. Do clients need additional insurance, or do these standards remove this issue? I'll just kind of give my experience of that. So right at the start of the process where we were looking to reuse steel, I spoke to our PI insurers, and our PI insurers are happy that as long as we're designing to known data about the steel, it's no different really to reusing elements of structure in situ. And they didn't have an issue with it, as long as we could, again, show that we knew what we were doing and that we were using the test data for that steel. Do you have a view on that, Peter?
Yes. So I would say engage early with your insurance broker for larger projects and with your insurers for the smaller risks. Sort of the knowledge sharing is key, so we want to know about your project and your plans and the risk associated with it.
Okay. Another question.
Penny, can I?
Yeah, sure.
We engage with our insurers, and they want to be notified on reuse jobs. So on the next few, we're doing it on a job-by-job basis. When it becomes more prevalent, it might go into the annual prelims, but currently they want to know about it, and we're advising them on a job-by-job.
Yeah, I think that's good advice generally, just to let your insurers know if you're doing anything that's maybe not quite business as usual. There's loads of questions here. I'm not sure about timing, how we're doing for time, but I'd quite like to cover a bit on specifications. And then we come back to the questions, if that's okay. So next bit we wanted to cover is specifications, and I'm going to kind of split that into two halves. So at the beginning, if say, Laura or I are involved in an early stage of a project, we've got an existing building, we know there's steelwork in that existing building, and we want to try and salvage that steelwork. How do we go about specifying that, and how do we agree what's acceptable in terms of the steelwork that comes out of that building? And I know Laura's been through that process. We've been through that process at Elliotwood. So, Laura, do you want to give a bit of an overview on what needs to be considered?
Yeah, sure. So I'll give an example from a project-specific viewpoint, the one I mentioned before, Cundy Street. So the levels of damage and the tolerance for damage in the British standards currently is extremely tight, and that's what reused steel currently has to meet. So it's basically far too onerous for realistically for reused steel to meet the damage criteria and the tolerance and the tolerances for in the current British standards. So, and this is especially if it's in a challenging building like at Cundy Street, which was concrete encased, which means a lot of damage will happen to the steelwork as it's being deconstructed. So we knew it would be really hard to balance the decasing and the extraction with the levels of damage sustained by the steelwork. But actually, we were on site while they were doing the deconstruction and the decasing, and we were watching them do it and had them do it by two different methodologies, so one by handheld, one by kind of machine breaker. And actually, most of the damage occurred before we got to site as they were breaking out the slabs. So most of the damage we saw were kind of dings to the top flange. And so this is a lesson learned that we should have been there earlier and should have considered that actually the damage to the top flange before any decasing happened was the most critical. And so the lesson would be to leave the beam strips intact next time and then carefully decase anything around the steelwork. And then in terms of assessing the damage that was done, basically, we've just been through that process. All of the damage exceeds the minimum or the maximum levels of tolerances in the British standards. So we need to take a view on what actually the implication of the damage is. And in general, in terms of being acceptable for reuse, we can evaluate damage on a kind of case-by-case basis, but that makes it a bit tricky because it means that an element could be useful for a certain use in a certain configuration based on the damage that it has sustained. So, for example, if the top flange has been a bit warped because of damage during deconstruction, that beam could be flipped over, that flange could become the tension flange, and the dents would have less of a structural impact. Obviously, it's not quite that straightforward, but you could envisage a use where the damage might not be so critical. You could envisage usage where the damage would be very critical and it wouldn't be able to be reused. So trying to navigate that landscape, I don't have any straight answers for you because it's really quite nascent, and it's really hard to say you need to reclaim the steel in perfect condition because that's just not realistic. It doesn't work on site. It adds about kind of 3 times, it makes the deconstruction 3 times longer. It's difficult to communicate the processes, even from the site office to the operatives on site. We found it really challenging to really explain what we wanted. And so I think we need to have like a lot more lived experience on exactly saying how to deconstruct buildings so that they result in a level of damage that are acceptable, and also accept that they won't meet British standard levels of tolerance currently because they're way too onerous for steel. Having said that, this is a really challenging case. Concrete encased steel is going to be obviously one of the more extreme cases. And actually, for a lot of the beams, when they were decasing them, they were being quite rough, and they cut the ends off and dropped the steel down onto the next level down. And we were worried that that would be, really damaging, but actually almost all the damage was due to the top flange, removing the slab over the top flange. So it was good to see them being kind of rough with actually limited effect.
Yeah, thank you, Laura. That's a really helpful example. And from your point of view, Jonthan, obviously at some point that steel is going to land in your factory. How does the level of damage impact what you need to do as fabricators? And can you give maybe an example of what can be acceptable and what is completely off the table?
Yeah. Just before I talk about the fabrication shop, I think the tolerances need to be thought of on a local level in terms of admissibility, but on a global level as well. NSSS has a lot of tolerances in it for depth, camber, straightness, and all of those sorts of things. It's not unusual for us to see tolerances half that in the jobs that we do in and around London. If you've got a reused beam and tolerances are being specified in the floor plate to meet certain head-to-head height requirements, those local tolerances start to affect the global tolerances that we play with. Same might be true for edge beams where there's an interface with a facade contractor. So I think it's important to have a view on tolerances from a local and a global perspective. In terms of fabrication, everything we put through the shop is either on its side or on its belly. A nice new piece of steel will obviously slide through quite quickly. Dints and dents might mean that they don't sit on the beds as reliably. The truth be told, it's not tested yet, but we are forecasting slightly slower throughput times currently for reuse steel. And as the data becomes more available within our business, we'll speed those up accordingly. But everything's automated, saw, drill, punch, and the smoother it goes through the roller lines, the better. But the rewards are high, so we are, at the moment, forecasting slightly slower fabrication times.
Okay, thank you. So I think that's a bit on the deconstruction side of things. I think at the moment we're obviously in a transition period. We've got some really great projects out there that are happening, live projects, and we're actually doing this. But I think we're still a long way away from the utopia of having a fully developed second-hand steel marketplace that I think a lot of us are aiming for. So when we get to that second-hand marketplace, I think we need to be able to, in an ideal world, specify what type of steel we want to see or what type of steel we want to use on our project. So I wrote a thought piece a year or so ago, which was of different specification classes. So whether it's essentially brand new steel that just hasn't been used, or whether it's steel that's got holes through it, whether it's got fittings on it, whether it's been sat out in a yard for a year, it's got a bit of rust. What's acceptable in terms of that steel? And I know that others, EMR, are doing their own sort of specification, classification at the moment. David, how far away do you think we are from getting to that point? And do you think that is a good way forward?
This is a provocative question, ladies and gentlemen, because I think the engineer is responsible and has to be responsible, as Laura was saying. So my view is, the example was a beam where the flange had got some problem, we'll turn it upside down. We would know that a hole might be a problem near the end, but not in the middle. So in my view, to provide some sort of overarching quality level is a good ambition, but I think that might be quite limiting. So I think that's optimistic, but I'm a little bit skeptical that we'll achieve that.
And Laura, your view?
Yeah, I agree. I do feel quite strongly that the acceptable grade depends on the end use, and that does complicate matters a little bit. When you're looking at big stock in a stockyard, there is a bit of interpretation needed. Having said that, though, I think the idea of having, as you wrote in your thought piece, Penny, at least a loose system to understand whether you're going to have to look at this really clearly and evaluate damage from a structural perspective, or if you're pretty sure it's just basically clean, no holes, no dents, that will help the process. It'll help focus the mind on the important bits.
Okay, thank you. And Jonthan, from your point of view, presumably provenance of that steel plays a part in any sort of future classification system. For instance, you could have steel that's out there that you don't know anything about where it's come from, whereas you could have another piece of steel that comes with its full test certificates. I know which one you'd pick.
I think it's fair to say we would pick that, but equally if we got a piece of steel that didn't have a defined provenance but had all of the testing regime, we wouldn't be adverse to using that. It comes back to the stakeholders within the business, the technical versus the non-technical. I think the non-technical would take the provenance steel, defined steel every day, but it's an education piece, and they'll become more and more comfortable with the trading relationships that we're building with Cleveland and EMR at the moment as time evolves. So I think it'll become less of an issue, the provenance of steel.
Thank you. And just one further question, really, from me, Peter, in terms of insurance. This came up in our pre-meets that we had before this panel, a question that Michael posed. So if we had a reused steel beam in a building, it's been in use for a couple of years, and God forbid there's some sort of failure to that beam, would that be treated any differently to a new piece of steel from an insurance point of view?
No, because it went through the supply chain, being recertified. So I don't see why it should be treated differently. Obviously, you will have to think carefully about your warranties and contractual relationships. You can also purchase latent defect insurance for this piece of steel. But in general, I would expect the steel that arrives on site to be no different to a newly fabricated steel. We would expect to have corrosion protection in place, your fire protection, and good detailing around connections. And in terms of the tolerances, I think we would expect that to not have a knock-on effect on the follow-up trades. So we have to think about that as well.
Thank you. So I think we'll come on to some questions in a minute, but final remarks. One last question to you all. So if you could each say one thing that needs to change to make this mainstream, what would it be? And we'll start with you, Laura, and work our way back down to me.
Sure. So I think for me, the one thing that we need is getting used to deconstructing and feeding the feedstock, because for me, it's the biggest issue. We can't encourage reuse of steel without also encouraging reclamation and feeding the stockpile. So yeah, deconstructing buildings.
Jonthan?
I think we need to walk before we can run. There's lots and lots of technical innovation, digital innovation, that is meaning there's an over-demand for reused steel. And currently there are very few large-scale examples of it being used. think we almost need to pause for a moment and prove what we think is true. That'll help the technical view, it will help the commercial view, and it will help the contractual view moving forward.
Thank you. David?
More widespread acceptance that reused steel can be CE marked. I believe it can, and Michael and I'm sure the panel think it can, but there seems to be some resistance to that. I think my other comment would be if you strip away everything, if you strip away the requirement for CE marking, if you strip away tolerances other than floor heights and elevations and things, if we as engineers met a piece of steel, we would look at it, we would measure it, we would test it, and we would be confident then about using it. You know, fundamentally, there is no problem. So it's sometimes the things which are surrounding that which is giving us a problem. It's not the engineering. So to me, more widespread acceptance that it can be CE marked, which I believe is the case.
Thank you. Michael?
I think repeating, I think it's all to do with availability. You know, we need more reclaimed steel coming on the market to reuse. Obviously, that's going to take time. Part of the work I did when I was at SCI was to develop this database of new steel buildings, cloud-based database, which we will populate over time. And I still think if somebody wants to pay for that, that's a great thing to do. We developed a prototype, but we couldn't commercialize it. But there are challenges today. I think they're all technically, and as you've heard, they're all we can overcome all those. But we need to start collecting the data now to facilitate future reuse. The one other point I would just make, as I see the projects going on, whether it's refurbishment of buildings like M&S Oxford Street or whether it's reuse like Holbein Gardens, etc., I think it's more exciting for engineers and architects to do these sorts of refurb and reuse project is more challenging, and I think that's more interesting, and we should sell that aspect as well.
Thank you. Peter?
Construction underwriters use claims data to help them price construction projects. As you can imagine, it's very limited for reused steel projects. So I think we could maybe produce some inside guidance for underwriters that often are non-technical people, to provide some comfort and outline how we're going to manage the risks going forward.
Great, thank you. I think they're all fantastic points, all of which I would make myself as well. But I think I'll probably, for mine, it's what I always say on these panels, which is we just need to have better records of what's in our buildings. That will help for reuse, just generally, reuse of entire buildings, reuse of materials, and you know, the idea that the SCI came up with Michael's work of keeping all of the steel frame details in a centralized database, I'll be all for that. But just generally, clients, please keep better records of your drawings, of your buildings, so that we as engineers and designers can work out what's there in the first place. And that will just de-risk the entire supply chain, in my view. So thank you. Do we have questions to go back to? Wow, okay. Right, so should we just start at the top? Bill, what additional information do fabricators require so they can refabricate in the most efficient manner and not to add unnecessary costs?
Thanks, Bill.
Big question there.
I think we're already going in the right direction on that. The work we've been doing with you guys on model sharing is proving useful. We just need to cut our teeth on it practically. It's the holes, it's the car damage map analogy that you came up with. It's knowing where the stiffeners are so we can align the steel so it doesn't clash with existing connections. Until we've run a large-scale project, we just don't know how much more time it's going to take. And I think you accept that, and it's going to take a few jobs until we can sort of say, yeah, it's business as usual. But at the moment, we're foreseeing slightly longer engineering times to coordinate it with all the existing fittings. And the easier you make that for us by communication, the quicker we'll get to that destination.
Great, thank you. Question from Duncan here. Is it more straightforward if steel frames using reclaimed steel are bolted together instead of welded, better for future reuse potential? you could probably answer that one. I think, in theory, well, when we started this process a couple of years ago, I was under the impression that it would be better and that all of the steel beams would be unbolted on site. But, I mean, Charlie's here. I'm sure there are other demolition contractors in the room. What we're actually finding is that just they're being cut out anyway. So unless you're taking down a whole steel frame to essentially reassemble it in exactly the same or pretty much exactly the same format somewhere else and relocate the entire building, what we're finding is that they're being cut out as full lengths. And that kind of makes sense when you think about it. If you're trying to salvage that steelwork to then reuse it in a different building, you're going to have to cut the plates off either end anyway. You're going to have to put new connections in anyway. So, yeah, I mean, I think whilst all the books say bolted connections, I'd question it a little bit now, unless you're looking to relocate the entire frame.
I would just add to that. That you sometimes sterilise the end connection with holes anyway. So if you theoretically could dismantle it, you'd reveal the holes that were used to bolt it up in the first instance. Who's to say you can use them 100% for the new connection? So I think you're right. I think there's a recognition that you can have a degree of rework regardless.
I think it's supplementary. Yeah. We've seen some projects that others better to answer that technically, but yes, we've seen some projects where the steel is old and its provenance slightly uncertain. They were bolted connections rather than welding end plates, etc. Yeah.
I think if you take it as in a perfect world, then yes, we would have almost an infinite amount of time. We could try and work with the connections that we've already got, but in this commercial world that we live in, I think the reality is that the risk for demolition contractors of unbolting every bolt, the risk to program, etc., of doing so, and also utilising the skill sets that they've already got in their demolition teams has meant that they're just using oxy-torches to cut them out. They have changed their methods because normally they will cut at sort of a 45-degree angle. So if you've got a 600 deep beam, you lose 600 mil at the end of that beam. Whereas now, on the large one that we've been involved with, they're cutting straight cuts so that you're actually maximising the length of the steel. But yeah, in a purely circular economy, reuse, theoretical way, every time you do that process, you're losing a little bit of steel. So eventually, the length of the steel will become too short. But I think we're in a sort of transition phase at the moment, aren't we?
It's also building topology related, isn't it? I mean, most of the projects we're thinking about and talking about today are central London multi-storey, whereas if you're dealing with portal frame sheds, it's a lot easier to unbolt, and you're at low level, you can access the connections and you can unbolt and reclaim the whole rafter possibly. You've got issues with the haunches, etc. But most of the buildings in the press at the moment are high-rise, which is different to reclaiming the full rafter in portal frame sheds.
Tom, so we've spoken a lot on yield testing and validation of the material, but what about taking into account defects, holes, and damage in the members on removal? You would like to answer that one? We kind of covered it a little bit. Anyone got anything more to add on that? No,
I think it's the same as we said before. It's a case-by-case basis, isn't it? I sympathise with Laura because you need to know where it's going to be used. Something could be entirely usable in some situations.
Thank you. One from Zoe there. What could be considered to reduce the cost of testing?
I think simply doing more of it. If you're doing loads more, you just bring the unit cost right down. I think that's all I can say. I mean, do you have any test houses in today? I don't think we do. I know Sandbag have joined our BCSA group, and they're interested in this space. But I think other than economy of scale, I don't think there's an easy answer to that.
Are the standards applicable or appropriate for non-structural steel, i.e. cladding? One for you, David? Michael?
Well, I can answer it. So, well, partially answer it. So following up to the question there, so we did a large project which really was the European project, which was the background to P427 really, but the focus of that was entirely sheds, industrial buildings. And we've always focused on the primary structure because that's robust enough to reclaim, and in those building types it's relatively easy to reclaim. In that project we did also look at secondary steelwork and cladding, and yes, we made some progress and new developments, etc., but it's still the condition and the fragility of other types of steelwork like cladding and secondary steelwork just really isn't ready yet, I would say, for sort of mainstream reuse.
Thank you. Please keep moving around. I just when I was reading. Very good. Question at the top there from Mike Brooks. Do we have good data on fire performance of reused steel, particular cellular beams? Anyone put the hand up for that one?
I don't know about data, but the reused steel you can't reuse any existing fire protection. It has to be removed and reinstated. So I don't know how it would differ from new steel, unless one of my co-panelists can prove me wrong.
I agree, yeah.
Yeah, that was going to be my response as well.
There are, particularly with fire engineering, so Jonthan, particularly thinking about the program that you guys have been involved with F-beam and stuff, is that there's a very specific suite of test data that all of that is based on. And are there conservatisms that we need to put into the fire protection because we can't necessarily apply that fire engineered approach because we don't know, do you run those beams, those existing new beams, as new beams, and make some conservatisms as to the fire test data behind that? Or, how do we approach that?
I think we would, because the way the F-beam, for example, works, it's elemental. So it looks at the web, it looks at the flange, it looks at different areas around openings. So it's the material local to wherever the hotspot is and finds the thickness. I think something that I've just thought of that maybe we would take into account is that the unity could potentially be different on used steel because of the gamma factors that David was alluding to earlier. But a lot of the fire engineering starts off life as a prescriptive method anyway. So it's a cellular beam, it's a column. So those limiting temperatures derived are fairly conservative, and it's only when you start to fire engineer the beam you want to think about the ETA5 value and the impact that reused steel has on that, because it could increase the ambient stage unity slightly. It's a good point. I'd not thought of that element, but yeah.
Thank you. Okay, next question from Nick Cole. How can salvage of steel for reuse be incentivised through demolition specifications to reduce the level of damage? I think there's probably a wider question around that as well, about just generally stimulating supply of steelwork as well. But on that specific point, Laura, do you have anything to add from what you were saying earlier?
Nothing helpful, unfortunately. I think it's just by doing it and by learning from practical lessons that we'll start to sort of trend towards a better answer to that question. But yeah, from my personal experience, I don't really have anything more to add than what I've already discussed.
I mean, I think I haven't seen it in demolition contracts, but we are starting to see contracts where clients are specifying, say, carbon targets or a percentage of materials to be reused targets in their contracts with contractors. So I don't see any real issue to actually try and bring that to the fore and put it into the demolition tenders. And I've been kind of advocating for that for some time, that traditionally demolition contractors are usually procured on who can get the building down quickest and most cheaply. That's not good in English. The cheapest. And then there's a little bit on health and safety as well. So we should, I think, be bringing in more metrics to try and stimulate that side by putting into demolition tenders that they will be getting more points if they're able to salvage more materials from that building. I think that's a whole other topic we can discuss. But yeah, I think we should start to put more of these metrics into these different tenders and contracts. Has anyone else got anything to add on that point?
Not linked to demolition, but I'm a bit wary about having a one-liner saying you must use 10% reused steel without any due diligence put into a contract. I'd be nervous of that. I think if the engineers can start and say, if stock levels permit, this could be reused, this could be reused, and do a bit more of a global sense, then I think it'll get embraced much more.
Agreed. I think it's important with that early collaboration that we were talking about. Yeah. Can the steel that is actually tested be reused, or is that then treated differently?
It can.
Absolutely.
Yeah.
Yeah.
There are some case studies.
Yeah, that's a resounding yes.
And also just to say that the guidance that has been written by the SCI has design guidance in it, so it tells you what to do for designing with reused steel. So it's all straightforward. It's all laid out as already covered, I think, by David.
Thank you. Okay, David Bumby, what is a typical maximum design life which can be offered by a contractor for a reused beam from a 1970s building? That's quite an interesting question. I was asked a similar question from a large developer a few years ago, who basically was saying, if I'm demolishing a 1980s building, which is 40 years old, say, that means that if I take a piece of steel out of that building, it's only got 10 years of its design life left, which just really kind of almost knocked me sideways because I just finished a big project in the city where we were reusing in situ 1920 steel, and no one had even batted an eyelid, asked a question at all. So yeah, I think from my point of view, it's the same as new steel. I mean, steel, if it's kept protected and it's not any sort of wet and dry cycle or wet, then it should last for ad infinitum, really. I don't know if anyone else has got a different view.
When we offer design life on buildings, it's all about the paint system that we're putting on the steel, not the steel itself. Yeah.
There are limitations on what's acceptable in terms of fatigue with reused steel. You guys can probably talk into a lot more detail, but that's one of the criteria that makes it much more difficult / impossible to reuse if it has been exposed to fatigue.
Yeah. So if I could add to that, the P427 says we're excluding members which might have experienced plastic hinges, although generally you won't see them because you design for those at ULS. It excludes members which have been subject to fatigue. But then we need to draw back, don't we? And then we need to remember that fatigue is all about the details. It's not about the plain steel. There is not a fatigue problem with plain steel. So once you've hacked the connections off, it shouldn't be a problem.
Okay. Are there any trends with the costs of reused steel versus recycled? That's a question from Chris. I don't know if we're necessarily the best people to answer. I think there's probably better people in the room to answer that question. Does anyone want to have a go?
I'll try and indirectly answer it. We're currently experiencing that if you price new steel at a rate per tonne, you get very little waste, you get very little scrap. So the rate is fairly cognizant of the tonnage that you buy. With reused steel, there are examples where you have to uplift the section size. There are examples where you have to buy slightly more, sometimes as much as 10 to 15% more, to be able to cover the new application of the reused steel. So it's not necessarily the purchase rate of the reused steel that looks expensive. It's when you figured out what the scrap associated with it and what the uplift in the tonnage associated with it is. On one job, you'll have a fantastically aligned answer, and on another job, it is slightly higher. So we are experiencing quirks like that where on a rate-by-rate basis, it looks fantastic, but when you flush out the detail, it's coming up more expensive because you're having to buy more of it.
Thank you. Do you want to add to that, Michael?
I was expecting a similar question about carbon, and we did have it on our list, but it hasn't come. But more comfortable to talk about that than I think cost at the moment. But we and Elliott Wood, and certainly AKT2 and Arup have all looked at this tipping point between when it's better to reuse or recycle the steel. So that's a whole other issue. Maybe carbon is less sort of volatile at the moment than price, so it's easy to talk about it. But I think the consensus of those various studies is that if through reclaiming and redesigning using reclaimed steel, you're roughly about 25 to 30% heavier than were you to design that using new steel, then probably it's better to recycle it in an arc furnace and use new steel in terms of carbon. That wasn't strictly answering, but I think it's related.
Yeah, it's good to get it in. Yep, thank you. Top question there. Has anyone made progress with reclaiming composite steel beams? Anyone got an answer on that one?
We're seeing it, so
Yeah.
on your job.
Yeah, exactly. I was going to say it's probably best to leave that to the case studies next, because we, as Elliott Wood, EMR, GPE, and others, have got a case study coming up, which is from a 1990s steel frame building with composite floors. So we can talk about that one later. One for Michael, I think, from Jamie Hillier. What dialogue does BCSA have with the National Federation of Demolition Contractors around the shared challenges that we've been talking about getting this steel out?
To be honest, at the moment, not very much. When I was at SCI, we did do quite a lot of work with NFDC in terms of collecting data, but that was sort of before this whole reuse market sort of picked up. So I haven't worked with them closely yet regarding what we can do more about demolition side of things, but I definitely think we should get them on our BCSA reuse group, because I think what I'm hearing today is we need to do more from that side of things.
Yeah, thank you. Question from John Ward. With careful demo specification, the 1090 tolerances appear achievable in practice. What is the fabricator's view, 1090.2 versus 10034 for global tolerances? Very specific.
The point there was, outside of composite beams, you're probably not surprisingly finding that reclaimed steelwork is within the 1090 tolerances. Composite beams are a special problem because they get bashed. The top flange, as Andrew has pointed out, gets bashed to crap when they take the concrete off, and that's a separate problem to be dealt with in demo specification. But outside of that, on the basis you're not allowing plastic hinges, all of the steel was within tolerance when it went in, and it's still going to be within tolerance when you take it out. The problem is it's within the 1090 tolerances, the fabric has fabricated tolerances, not the as-rolled tolerances, and I'd be interested in, we've talked about this before, but interested in your views to the room on that.
I think the honest answer is I've got to do a bit more reading on it, John. I put my comment earlier on as a placeholder, because if you look at 1090 tolerances, we're probably fairly comfortable with those. We've traded. The point I was trying to make was it's not unusual, or I would say it's quite common, that people exceed the 1090 tolerances in project specifications. And that's when we have to slow new steel down to get it straight, to make sure it fits in the structural zone. And I think I've got to do a bit more reading, maybe chat to you offline about it. I think it's a risk that we just want to be careful about, of promising more relaxed tolerances for reuse steel without thinking about the bigger picture.
Can I just add to that? I guess we must get one call every fortnight about something which is important, where the secondary steelwork won't fit, or something is shown because it's deflected. And the answer is, we know it's going to deflect, build in provision for adjustment. If it's got to fit to some cladding or something like that, make sure that the cladding has got, the connections have got packs in, or they've got slotted connections or something like that. That's not an answer to your particular question, but it's a general comment that if something is so tight a tolerance, well, let's not believe it's going to be perfect. Make sure we've got provision for adjustment.
Okay, just one final comment there from Christian. There's a nice example of a 1942 hangar that was repurposed, relocated as a bus terminal at Schiphol Airport. So obviously we've been talking more about reclaiming steel, but we haven't really talked about moving entire buildings. But like you said before, Michael, you led on a research project which looked at exactly that a few years ago.
Yeah, it's just a different business model, and I think it does happen, particularly in the agricultural sector. You know, smallish portal frame sheds are regularly moved around, and there are examples like the Schiphol one that again I think has been moved twice before it became the new bus station at Schiphol. So yes, for those, which is why we did a whole project looking just at that building type, because they are the obvious low-hanging fruit for reuse, particularly at the building level. So yes, most of the evolving business model, particularly London-centric at the moment, is a different model to that, the one we're discussing more today. But yes, that whole building market is out there, and I think Roy can talk probably about that later. I mean, I think he deals a lot with that side, and there are other providers of that. It's not in the press because it's not all new and not exciting and not in London.
Yeah, and it is still happening. We've got a project at the moment where a client's bought a portal frame and they want to create a new workshop out of it. Not in London, outside London, but yeah, it is still happening. I think we need to wrap it up now. So thank you very, very much to our panelists. That was really, really good. I think we covered a lot of ground. So thank you to the audience as well for your questions.